Okay, we are in section 5.5 where we are applying the remainder and factor theorems. I think it was in intermediate algebra we talked about using long division to divide polynomials. I think what we did was when we used that process, it was with polynomials that didn't have as large of a degrees. I think we divided into maybe, I think they were just quadratics, where I think the largest one was x to the second power, and it was divided into something that was like x to the first. So this is very similar in the concept, but we're just using larger degrees for our problems. So just to keep that in mind, it's still the same rules apply, and let's work on some examples. So I have example A, where it's 2x to the fourth minus 3x squared plus 5x minus 4 divided by x squared minus 2x plus 2. So I'm going to use my long division. So I got my x squared minus 2x plus 2 divided by 4x. Oh shoot, I wrote that wrong. 2x to the fourth minus 3x squared plus 5x minus 4. So first off, I already did something wrong. First thing you have to keep in mind is that the same rules apply. So see how I have x to the fourth here? Now I have x squared, but I don't have x to the third power. We still have to add or input x to the third power into our long division. So how we write that is plus 0 x to the third. Then we can go minus x squared plus 5x minus 4. Sorry about that. So I look at my first coefficient, which here is 2x to the fourth. I need a value up here that I can distribute through these values, x squared minus 2x plus 2. It's going to cancel out that 2x to the fourth. And that value is 2x squared. So if I were to take 2x squared and distribute it to the x squared minus 2x plus 2, that'll give me 2x to the fourth plus, or I'm sorry, minus 4x cubed plus 4x squared. Okay, now just like what we did in long division, whether it was with numerical values or with polynomials, we're going to subtract these. So I'm going to subtract all of my values. So what that means is I'm going to change the sign in all of my values here in the subtraction. So I'm going to have a minus here. This is going to be a plus, and this will be a minus. So this cancels out. This becomes 4x cubed, and this becomes minus 7x squared. Now we drop this down to become 5x, and now we have to find a value that's going to cancel out 4x cubed. So that's going to be plus 4x. I distribute it out, so that becomes 4x cubed minus 8x plus 8. This is 8x squared. Then this is 8x. Okay. So I subtract these out. So make the bottom ones the opposite sign. So this becomes negative, this becomes positive, and this becomes negative. So this cancels to become 0. Here I have negative 7x squared plus 8x squared, so that just becomes x squared. And then I have a minus 3x. Last one, I drop this down, minus 4. Now the last thing I need to do is I need to find a value that's going to cancel out my x squared, distributing out my x squared minus 2x plus 2. And that becomes a plus 1. So I'm just going to multiply everything by 1, so it just becomes x squared minus 2x plus 2. And changing the signs, negative, positive, negative, cancels out. I have negative x minus 6. So the negative x minus 6, since I have nothing else I can divide out, or that becomes my remainder. So my answer becomes 2x squared plus 4x plus 1 plus my remainder, which becomes negative x minus 6 divided by this value. So I have x squared minus 2x plus 2. And there's my answer. Let's look at example B. So I have x cubed minus 4x squared minus 8 divided by x squared plus 2. So again, I'm going to take a look at this x squared plus 2. I don't have an x in between there, so I have to rewrite this as x squared plus 0x plus 2 divided by x cubed minus 4x squared. And I don't have an x here, so that becomes a plus 0x minus 8. So now as I look at this, I need, first thing I need to cancel out is my x cubed. So I'm going to first distribute an x. So this becomes x cubed plus 0x squared plus 2x. So changing the signs, negative, 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 cancels out. This becomes a negative 4x squared, and this becomes a minus 2x, and I'm going to drop down my negative 8. So now I need to find a value that's going to cancel out this negative 4x squared, and that'll be negative 4. So when I distribute out the negative 4, it goes negative 4x squared minus 0x minus 8. So changing the signs, plus, 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 and this cancels, it's also this one, but the only thing that I'm left with is a negative 2x. So that's my remainder. So I can rewrite this as x minus 4 plus negative 2x over x squared plus 2. You don't have to write in the plus 0x, it's not necessary. So there's your answer. The other thing is they talk about is the remainder theorem, and they say if a polynomial f of x is divided by x minus k, then you can use the remainder as r equals f of k. So here's basically what that means. So if you're taking a polynomial and you're dividing it by a value that just has a variable to the first degree, you can use synthetic division. And this is where the x minus k comes from. And in this example, we're 4x cubed plus 9x minus 7 divided by x minus 2. Our k here is 2. So here's how you write it out as synthetic division. So if our k is 2, so I'm going to write that on the outside of our little half box. Then we take the coefficients of our polynomials. So our first one here is 4. I don't have an x squared, so that becomes 0. X is 9, and our constant is negative 7. So we're going to use do the same process as we did in previous sections. So I drop down that 4, multiply that by 2, so that gives me 8. Add those together, that's still 8. 8 times 2 is 16. 16 plus 9 is 25. 25 times 2 is 50. And then you add that by negative 7, that gives me 43. So this value here, the 43, is considered our remainder. This value here is our constant. This value is x to the first, and then this is x to the second. So when we write out this answer, it will have it as 4x squared plus 8x plus 25 plus 43, which is our remainder, divided by x minus 2, which was what we divided it by. Okay. I'm going to give b a try. So I have 9x to the 5th minus 8x to the 4th plus 3x minus 6 divided by x plus 1. So here our k is negative 1, because here we have, this is x minus k, and so if k is negative 1, that's where we get the plus from here. So again, same thing, negative 1, little half box. So my x to the 5th is 9. X to the 4th would be negative 8. I don't have an x to the 3rd or an x squared, so I write those as 0 and 0 as my coefficients. And then x is 3 and my constant is negative 6. So I drop this down, it gives me 9. Multiply that, that gives me negative 9. Negative 9 plus negative 8 is negative 17. Multiply negative 17 times 1, that's just 17. Added by 0 is 17. Negative 17. Negative 17. This becomes 17. Add those to get added to 3, it's 20. Multiply by 1, that's negative 20. And add those together, it's negative 26. So here is our remainder. 20 is our constant. This here is x, x squared, x to the 3rd, and x to the 4th. So we write this out as 9x to the 4th minus 17x plus 17x squared minus 17x plus 20 plus a negative 26 over x plus 1. There you go. The other theorem we have is the factors theorem. Again, we can use synthetic division again in order to factor these out completely, as long as they give you something to factor it out with. So for example A, I have 9x to the 3rd minus 36x squared minus x plus 4, and they want you to factor this out completely. You can use synthetic division here because they tell you that x minus 4 will be one of those factored out completely binomials. So you can treat this like the x minus k here. So k would equal 4. So I can write this out and in here have it as 9, negative 36, negative 1, and 4. Drop down the 9, multiply by 4, that's 36. Add those together, that's 0. This becomes 0. Negative 1, negative 1 times 4, negative 4, and 0. So I have a remainder of 0, and this negative 1 is my constant. This is x, and this is x squared. So now I can say that I have x minus 4 multiplied by the quantity x squared minus 1. Now I can factor this out even more because this looks like the difference of two squares, so I can say x minus 4 times the quantity 3x plus 1 times the quantity 3x minus 1. And that is how I can factor out this polynomial completely. Let's take a look at B. I want some more room, so that works. So here I have g of x equals x to the fourth plus 16x cubed plus 25x plus 250. And I know that x plus 2 will be part of my factored out completely sequence. So I can still use my x minus k here. So that means k is negative 2. And my coefficients would be x to the fourth is 8, x cubed is 16. I don't have an x squared, so that becomes 0. X is 125, and my constant's 250. Drop it down, I got 8. Here I have negative 16. That's 0. Multiply that, that gives me 0. This gives me 0. Here I have 0 again. 125. Times that by 2, that's negative 250. And that's 0. So I have, this is my remainder. This will be my constant. This is my x. This is my x squared. And this is my x cubed. So I have right now for this polynomial, I got x plus 2 times the quantity 8x cubed plus 125. Now, looking at just my 8x cubed plus 125, that looks like the sum of two cubes, where if we go back into our notes, where the a would equal 2x and my b would be 5. So I can factor this out even further. So I have x plus 2, then I have, and then I can just plug this into my formula of the sum of two cubes. So this is what, 2x plus 5 times the quantity 4x squared minus 10x plus 25. And that is factored out completely. And that is applying the remainder and factor theorems. Hope this helps. Until next time.